Hi, this video is going to cover basic trig functions. So sine, cosine, tangent, and how to use those to find missing angles and missing sides of a right triangle. So first thing is, this is over the trig ratios. And the first thing we really want to focus on is how to kind of memorize the ratios and what to kind of use to try to get them in your brain so you remember them without having to look them up every time. So I'm going to give you my little trick, and I'll give you a couple. So there's sine, cosine, tangent. So I always say sine, cosine, tangent of an angle. This is a theta, and it just means an angle, which will make a little more sense when we define what these are, but I learned, oh heck, another hour of algebra. So sine, cosine, tangent, oh heck, another hour of algebra. There's another one that goes S-O-H, SOHCAHTOA. So you just use, that way you could get your sine, cosine, tangent right. So SOHCAHTOA. So when you start trig ratios on any test, anything, what you start with is you get out a piece of paper and you write those down so that you remember them as you work through the homework. Okay, so let's draw a triangle and kind of define what is OH and A. So we have to have a right triangle. I'm going to have to move this out of your view for a sec to make my triangle pretty. Okay, so we have to have a right triangle because these are right triangle trig ratios. So you always have to have a right triangle. And across from, or right triangle, right angle, across from the right angle is always the hypotenuse. And that's what we are using for our H in our definition here. And from an angle, I'm going to call this angle over here theta because I had called them theta here. You could have called it A, B, C, D, whatever. But from this angle, which is different than if I would have used this angle, the opposite angle from this one is here. So this one would be our opposite. And then this one would be our adjacent. And it matters because if I would have said theta was here, that would have been opposite, that would have been adjacent. So you have to be careful of that when you start looking at the trig ratios. But for our definition, we have our basic definition here. Let's look at like another triangle. Maybe I'll draw it like the opposite way. Oh, that's pretty for not using my ruler. Okay, so what if I said this is A, this is B, this is C, this is little c, this is little b, and little a, and I want to know what is the sine of A. All right, so we know sine is opposite over hypotenuse, and it's going to form a fraction. So A is here, so opposite is A. And hypotenuse is C, so the sine is A over C. Now they may have put numbers in there for you or letters, but you will do a couple problems where you're just defining what is sine of A or what is sine of B. So sine of B is not the same, right? Even though it's the same triangle, because from B, little b is opposite, and then C is still your hypotenuse. So it's different from B. And it's a different angle, and we could keep going and do all the tangents and the cosines and everything. So you just have to pay attention to which one's which from which angle. So I'm not going to do all of them on that, but let's look at how would we use this information to find missing sides of a triangle. So this first one, we're going to find a missing side. Okay, so let's say this is X, this is 20, and this is 35 degrees. Okay, so I have this information, and I want to find X, this missing side over here. Well, let's look at what we know. We know here's an angle, and here's our two sides. From this angle, this X is opposite, And this is our 90, I should have labeled, so this is hypotenuse. So we go up. Which one uses opposite and hypotenuse is sine, and yeah, I will use the other ones. I've kind of stuck with sine so far, but so we would write this as sine of 35 degrees because we've always just labeled an angle like a theta or an angle, and that sine of 35 is going to equal x over 20. Then from here, it gets a little tricky. You have to use your calculator, but when you use your calculator, you have to be careful that you have it in degrees. So on the graphing, it's a little trickier. On the little ones, which I don't think I have any little ones with me. Oh, I have one on my phone though, and that's what a bunch of people use. So maybe I'll show that one. Calculator. Okay, so here's the basic calculator. Oh, that glare. And if I turn your phone or your tablet, you can get the full calculator here. And this one has the sine, cosine, tangent over here. And it has radians. RAD stands for radians. And it should have degrees as well to put it in degrees. This one must automatically do. Maybe this one automatically does degrees. Let me double check. So I know, and this one's backward. You have to hit the number, like we have 35, and then hit sine, and it'll give you the decimal. So this one's kind of backward. And this one does automatically go to degrees. And then if you want it in radians, they have a key for that. On this calculator, you have to hit mode, and you have to go down and make sure it's on degrees here in mode, and mine is, so I'm going to get out of that. And then, so from there, what I have to do is I have to find sine of that degrees, which I just did. It is always a decimal, so it's 0.5736 if I round, and it's x over 20. And then I keep solving, so I have to times those two together. So what I like to do in my calculator is, if I've already got the number in, man, I wish that would, there we go. I already got the number in. What I do is I just click the times button and it'll come up with the answer before and then put the 20. So I don't have to write out that decimal and make sure that it's correct. We would get 11.47 for x. So this side over here is 11.47. Now if I wanted to find this side, I could use cosine because 35 is adjacent to this side over 20. So I could then go into a cosine. So maybe I'll do that instead of writing out a new problem. Let's find, we'll call it y, whatever we want to call it. So this one would be cosine. My computer's a little in my way here. So this one would be cosine of 35 degrees is going to equal y over 20. So we do it the same kind of way on our calculator. I'm going to click the cosine button, and that'll bring up the cosine. And I want cosine of 35 degrees, and then I'm going to end that, and I get cosine of 0.819. Okay, so I have 0.819. 2 if I wanted to go one more place, either way. And then I have to times that by 20, so I'm just going to click times, and that'll come up with the answer before 20, and I get 16.38 or 16.4. You have to pay attention to what Math Excel or my Math Lab wants for your decimal, so be careful of that. But here we are. We've got both sides, x and y, and our 20. Okay, so we've used both sine and cosine to find both of those. Let's look at one more example of a side, and then we're going to go to trying to find a angle. So let's see here. Let's do one that looks like this maybe. Whoop. This is my 90 here, and let's say this is x, this is 10, and this one is 25 degrees. Okay, so what do we have from our degrees? We have two other sides, right? We have opposite and we have adjacent because this one's hypotenuse. So we'd go back to our trig functions and we'd say, okay, well, which trig function was opposite and adjacent? That's going to give us that tangent. So I would say, okay, tangent of 25 degrees is going to equal 10 over x. Opposite over adjacent. Now this one's a little trickier to solve, so let's start with a decimal for tangent. So I'm going to click tangent of 25 in my calculator equals 0.466. So I'm going to get 0.466, and that equals 10 over x. And if you end up with one like this, which you will, there's two ways you can think of it. You can say, okay, I'm going to think of this over 1 and cross multiply. Or you have to think of it as multiplying the x over and then dividing over the number. But we could think of it kind of like this way. I think that's probably the easiest way for most people. So 1 times 10 would give us 10. And we cross multiply the x times 0.466 is x times 0.466. And then to get the x by itself, we divide by the 0.466. So you end up with 10 divided by the 0.466 is going to end up with our answer. So I'm going to get 21.4 is equal to x. Okay, so 21.4 is equal to x. And it could be, well, if we round the 5, yeah, 4, 5. I had gotten 4.6 the first time. I think, oh, I see. I rounded out one more place. I was thinking that I had it, hadn't rounded right, but I did. I just went out further last time. Okay, so tangent, cosine, sine, it doesn't matter which one you use. And sometimes you can use more than one in one problem, and that's good too. Now, what happens if we don't know the angle? So these ones are harder. So if I don't know an angle, so I don't know this, but let's say I know this is 5 and this one's 14. So what do I have here? From the angle I'm trying to find, I have opposite over hypotenuse, which is sine. So we're going to go, okay, so sine of x is going to equal 5 over 14. And where this gets a little tricky is there's actually a button that does it's called an inverse sine, where it'll find the degrees for you. So what I do, I have to have sine of whatever letter is equal to this number here to be able to do it, or equal to a number. So on this calculator, they are right above your sine is the inverse sine, and the symbol for inverse is a -1 to the power of. So I'm going to hit second sine, and that's going to pull up sine of -1, which is inverse sine, and we want that of what, 5/14? So I'm going to do 5 divided by 14 into my parenthesis so that it does it correct and I get my answer. So x is going to equal 20.9 degrees. And if you aren't taking notes, you probably should have been. Now I should have reminded you before question 4. But it is really important that you're writing these down in a notebook so that you have them to refer to when you do your homework or tests. Chapter test. You can't use your notes on the final. All right, let's do one more where we're finding the degrees. So let's see here, 5, 8, x degrees. I should have probably put a degrees on that one too. All right, so what's x degrees on this one? So from x, we don't have the hypotenuse, so the only one that doesn't work with the hypotenuse is tangent. So that one's opposite over adjacent. So we know this has to be tangent of x is going to equal opposite 8 over 5. And again, we'll just put that in the calculator of the inverse. So inverse tangent of 8 divided by 5, and we get 57.99 or 58 degrees. So x degrees is equal to 58 degrees. There we go. All right, so that's a good example. It does have you compare a couple other things and looking at some of the formulas. But I will stop there with my lecture. Let me know if you have any questions.